Hi, let us start with the new topic called as relationships. Well, we already have seen this topic. If you see here, database relationships, we already have talked. But here we have talked about relationships just theoretically. We didn't have created any queries, we didn't have written any kind of inserts and other things. We just have understood theory over here. Now it's time to do some hands-on work. Well, if you have not seen this video and if you have directly landed on this video, I request you to go through this complete series. This is an in-depth series, remember that? And we have talked about a lot of SQL related things. Okay, let's go ahead. Now here, when you talk about the relationships, it is a relational database. So here SQL relationship defines association between the tables, forming the backbone of efficient and interconnected data management. These relationships are established through columns known as keys and come in different types such as one-to-one, one-to-many, many-to-many. Remember that, one-to-one, one-to-many, many-to-many. Now, when you talk about the relationships are there because of RDBMS, Relational Database Management System, where tables are called as relations, and these two or multiple or one or many tables are connected with each other. They are in relation. They have some relation with each other. So generally, I already have talked about this, about the RDBMS, and inside the RDBMS we have seen what do you mean by entities, what do you mean by attributes, the things related to the paper which has been presented by EF Cord. You may see earlier videos. Okay, now relationship represents association between the tables in the DB. Relationships are based on the shared columns known as keys between two or more tables. So at the time of constraints, we have seen what is a primary key, what is a foreign key, and other constraints. We have talked about primary key and the foreign key. You may refer the video on the keys. Okay, one-to-one relationship. Now, what do you mean by one-to-one relationship? Now, let's do hands-on. So here is our person table and there is a passport table. One person can have only one passport. See, one person can have only one passport. Now, let's open the VS Code. And here, as usual, relationships.sql, and open this with the SQL notebook. Open with SQL notebook and use YTDB. This DB I have created. Now see, there are multiple columns available. Multiple tables available. I want to delete all the tables. So in the earlier video, I have deleted one by one, but you can do something like this. Drop database YTDB. Drop database YTDB. So complete database would be dropped with all the tables. So again, we can create a new database. Create a database YTDB. Create it. And then use YTDB, because we have deleted, we need to use it again, right? Use YTDB. Now, next thing, let's create the table to understand the first kind of relationship that is nothing but your one-to-one. Also, let me open the chat GPT for creating the dummy data. Well, I'm going to discuss about few tools that will help you. So let's create the person table first, copy, and I would be adding over here. If you can see, create table person, person ID is a primary key, person name is a varchar, and birth date is this. So sorry, just delete this and run it. So person table has been created. Now another table we need to create, passport table, one-to-one relationship. One person can have one passport. Now we are understanding one-to-one relationship. So I can add one-to-one relationship. One-to-one relationship. That is, one person can have one passport. One person can have one passport. Right? One person can have one passport. Now, how do you write insert on this? How do you write insert on this? Let us ask ChatGPT. Just get this table structure and just ask ChatGPT. Ask ChatGPT, please create 5 insert statements for each table. Also maintain the one-to-one relationship. Note that, see, you need to specify the table also. Note that here we can say, note that we are using which database? MySQL DB. Now it will give you 10 insert statements. Can you see? Insert into person ID, person name, birth date, copy. Let's go to our this table. So this is also important. Remember that deliberately I'm doing it in front of you. Otherwise I could have created this insert statement as I created create table and other thing. So third, this is fourth, and this is fifth. Okay, and here we can say records or person records. Run it, and can you see 5 things have been inserted. Similarly, let's create the records for passport. Passport records. Here you can copy, insert into. So don't copy it blindly. I know all these things, that's why I am doing like this. But whenever you copy and paste, insert into passport, name of the table, these values, sorry, these columns and these values we need to add. Okay, so second passport, third passport, third passport. Null, it has created, okay, 2 nulls. 104. Let's get 104 also. 104. Now you will understand what do you mean by a relationship. This is 103. This is 102. Okay, 102 we have. This is 103. Sequence doesn't matter. This is 104. Okay, let's add it. So here is your records, person record, and these are the passport record. Okay, now let's do one thing. Let's fire the select query. Select star from person. Also select star from passport. Now here, if you see person ID 1, person ID 1 over here. Now, what do you mean by one-to-one relationship? One record from the person table can have only one record inside passport table. So this is a one record. So this record is related to only one record. You will not find one more one over here, like passport ID 102, passport number something like this, and person ID 1 is not available over here, never. So one record in the person table can have only one related record in the passport table. One record in the person table can have only one record related in the passport table. That is one-to-one relationship. One-to-one relationship. What is one-to-one relationship? One record, can you see this person ID 1 is available only once inside this whole table. The person ID 1 is available only once over here. If you look at the create statement, person, passport. So person ID is referring to, can you see there is a unique constraint has been added over here. Unique constraint. What do you mean by unique constraint? Person ID won't be getting duplicated. There would be only one person ID available in a whole passport table, that is unique. And the person ID is referring to the primary key of the person table. So this person ID is referring to the primary key of the person table, right? That's how two tables are in one-to-one relationship. And these inserts will work in this way. And these inserts will work in this way. Remember that you cannot create the passport until you have a person, because there is a person ID. If there is no person ID, how can you create the passport? If there is no person ID, if there is no person available, which means that person ID is not created, then you cannot create this passport. That is nothing but what the one-to-one relationship is. I hope you have understood this thing. Let's move ahead to the next thing. One-to-many, customer and order. Let's create the table first, and then we will discuss one-to-many. So here I can say one-to-many. One table can have multiple records in another table. One table can have multiple records in another table. Customer, here you can say, just create it. Customer table have been created. Primary key is there. Varchar, email is varchar. Then order table. Then we can have order table. So here order ID primary key. Order date is of type date. Customer ID is int. Can you see there is a difference now? So you will say that, okay, this create. So this create passport and this create is same. There is no difference. If you see, there is a person ID and the foreign key references to the person. Only difference is that this unique constraint is missing over here. Can you see? One customer can have multiple orders. One customer can have multiple orders. Order ID int primary key. What happened? Order ID underscore int primary key. Create table order, customer ID. You have an error SQL syntax. Check the manual corresponds to the this order primary key. Create table order ID int order underscore ID int primary key. Okay, let's try it again. Do we have that table? Show tables. Mistakenly, did we created that? No. Int primary key. Customer ID order underscore ID int primary key. Order underscore date. The customer ID int. Foreign key customer ID references customer table and the customer ID. Check the manual. Are we missing the syntax over here? Just a minute. Oh, I got it. What's happening over here? So here order, do you remember we have seen order by clause? So order is a keyword, a reserved keyword. You cannot use order. See, sometimes you need to read it properly. Inside order by, if you have seen here, we have talked about group by, order by, and having clauses. Where is that? Can you see? Yeah, group by, order by, and having. Group by, order by, and having. So it is considering that order by. That's why there is an error over here. So change the table name. So first let me change it in the notebook. Order detail. Order details. Let's make the order detail table. Order detail table, and now run it. So there is no problem inside this, but we were using the reserved keyword. So it's good that you have encountered this scenario. Okay, now let's ask ChatGPT. Let's ask ChatGPT to create sample insert. Please create 5 insert statements for each table. Please create 5 insert statements for each table. Also maintain one-to-many relationship. Please maintain one-to-many relationship. Okay. Now, yeah, let's get it customer table. This is our customer table. Okay, I didn't write insert here. Okay, you can create it. You can create it on your own. So here, insert. Another customer insert. This insert. This insert. Fourth and the fifth insert. Create the customers we have created. So here I can say customer inserts. Then order inserts. then order inserts. So first order, second order, third order, fourth, and fifth. Run it. Okay, inserted. Now let's try to fire select star from customer. Okay, C I think is capital. Can you see customer IDs have been created? And then select star from order detail and do this thing. Yeah. Now see, one-to-many relationship you can see very clearly over here. Can you see the customer ID 1 has placed 2 orders? Can you see customer ID has been repeated 2 times over here? 1 1. The customer ID 1 has been repeated 2 times over here, which means that one customer record is having 2 order records, which in the another words, one customer record inside customer table is referring to 2 can be considered as n, which means that multiple. One customer record is associated with multiple order records. Can you see, one is repeated 2 times over here. This wasn't the case at the time of one-to-one. One customer can have only 1 record over here, one-to-one. One-to-many, one customer can have multiple records. That is the one-to-many. Similarly, there can be a case for the 2 can be repeated 10 times over here, right? There is no unique constraint available on the order detail table. So this is the one-to-many relationship. So presently we are just firing select star from customer, select star from order detail. But we can join the tables also. That's what the next topic is, we will see. Okay, so let's move ahead with the new concept, many to many. I hope you have got the idea of one to many. One record can have multiple records inside other table. One to many. Okay. Well, reverse relationship is called as many to one. Many orders are belonging to one customer. Many orders are belonging to one customer. One customer can place multiple orders. Multiple orders belongs to one customer. Many to one relationship. That is also possible. Okay, at the time of project you will get to know that part. So let's create new thing, many to many relationship. Now how many to many works? Let's go here, many to many. Now create table student, just create it. Okay, student ID, primary key, student name varchar 50, age is int. There are no other constraints are available. Then create table course. Here we can say create table course, created, course ID, primary key, and this thing. And there is a third table. There is an enrollment table. We are tracking the enrollments of the students. Now, can you see here the enrollment table? Look at the primary key. Look at the primary key. So student ID inside the enrollment table, there is a student ID int and the course ID this. Now this thing is called as one special key in the SQL. What is this? Write it in the comment box. So they have created the primary key of the 2 columns. The combination of 2 columns are creating the primary key? Write it in the comment box. What is this? Write it in the comment box. Write it in the comments box. There is a special name to this concept. We have studied that. We have studied that. Please let me know in the comment box what do you call it as. Now, if you can see, the student ID is referring to the student table. Student ID is referring to the student table. And the course ID is referring to the course table. Course ID. Here you can say course ID is referring to the course table. Student ID is referring to the student table. That is what the enrollment table. So what is the enrollment table? So enrollment table is that table which is pointing to the primary keys of both the table. Many students can purchase one course. One course can be purchased by many students, which forms the many-to-many relationship. Many-to-many relationship. So student ID 1 can enroll. So let's create the insert. So let's ask ChatGPT to create the inserts. And here we can say, please create the 5 inserts for each table. Please create the 5 inserts for each table. Also maintain many-to-many relationship. Do not create separate code blocks. Do it in single code block. See now. Yeah, see. Can you see the inserts for, just to save the time, I have done this thing, right? It has created this table. So let's write the insert over here. Let's write the insert for the student table. 5 statements have been inserted. The insert for the course table. Insert for the course table. This is the insert for student table. Now it will give error. Okay, no problem. This will also give error. Now 5 inserts for enrollment table. Right now, let us see. Just I have fired the insert statements. So here we can say select star from student, then another select star from course, and select star from enrollment. Okay, now see, so student ID 1 John Doe, student ID 2 Jane Smith, course ID 101 mathematics, course ID 102 history, 103 science, 104 literature, and the computer science. Now what is a many-to-many relationship? So you cannot maintain the many-to-many relationship in the second table. Many-to-many relationship properly maintained by creating the third table called as enrollment. Again, look at the enrollment table. Enrollment table would be having student ID, course ID, and the primary key is a combination of both student ID and the course ID. So primary key is a combination of both student ID and the course ID, and student ID refers to the student table. That's what the foreign key constraint is, and course ID refers to the course table. This is our table structure. Now if you see inside if you see inside the enrollment table, can you see student ID 2 times repeated? So student number 1 has purchased course, or student number 1 has enrolled for the course 101. Student number 1 also enrolled for the 102. Now see, student number 2 also enrolled for the 102. Can you see, one student can purchase multiple courses. Also, this course, sorry, not purchase, one student can enroll for multiple courses. So one has enrolled for 101, again one has enrolled for 102. Same is possible. So 3 also have enrolled for 101. 5 also have enrolled for 101. Can you see that? 3 enrolled for 103. 5 also enrolled for 103. Means one student can purchase many courses. One course can be in one course multiple student can enroll to this 101. To this, if you see the 101, how many people have enrolled for 101? So roll number, student ID 1 has enrolled for 101. Student number 3 has enrolled for 101. Student number 5 has enrolled for 101. There is no restriction. 101 can be purchased by any student, and any student can purchase any course. That's what the many to many relationship is. Right? Many to many relationship is maintained by third table enrollment. Many to many relationship is maintained by third table. Inside the third table, the primary key is a combination, and you are going to tell me what we call it as in the SQL. Right? Enrollment table refers to the student table. Enrollment refers to the course table. Now you will tell me what is this, and this is how many to many. Look at the structure. Look at the structure. This is how many to many relationship works. Well, that's all. We have seen a lot of things. We have seen a lot of things so far in this video. Relationships, right? Now about the keys we already have talked. What do you mean by primary key? What do you mean by foreign key? But just in the notes I have mentioned it so that whenever you refer, you should understand that. Now there are something called as cascading actions. What do you mean by cascading actions? Right? How do you define the cascading? Cascading action allow automatic propagation of changes across the related table when modifying or deleting the data. Okay, so this is not related to the many to many, or this can be related to any table. What is cascading? Let me tell or explain by means of one to many, customer and the order. Now consider that we delete this customer. Consider that we are deleting this customer. Right? Now, what should happen to this 1 and 1? What should happen to this 1 and 1? Because the customer is no longer available in our system. So this customer ID technically should also not be there in the system. So this is the customer ID 1, John Doe, right? Somehow I have deleted this customer. So it is considered that whatever records associated with customer ID 1 in the order table also needs to be deleted. Now how do you maintain that? By means of the cascading. So let us alter the table. See here, I am altering the table. Well, at the time of creating itself, we can do in the create only, we can do that. Over here we can write on delete cascade. See here, on Where is that on delete cascade? Yeah, alter table customers, add foreign key to the customer ID, references order details, order detail, references order detail, alter table customers, add foreign key customer ID, references to the order detail. Now in a order detail, we have order references to the order detail, and this thing, an on delete cascade customer. Okay, let's ask ChatGPT to create it. Well, I can type it also, no problem, but just to save the time, one too many, just create on delete cascade. Create, write alter query, write alter query to add on delete cascade. To add what? On delete cascade. Now here, if you can see, alter table order detail, add constraint, this foreign key, customer ID, references to the customer ID, on delete cascade. Now see what happens over here. Whenever something is getting deleted, whenever something is getting deleted from the customer table, related records need to be deleted from the order table. So I have given example. Let me revise it again. So customer 1 has placed this two orders. But what if I delete this customer? These two details need also to be deleted automatically. No manual thing is there, automatically. So let's try to, so first we can say select star from customer. Let's start from customer and then select star from order detail. Order detail. Now I would like to delete this John Doe. See now, delete from customer, where customer underscore ID is equals to 1. Yeah, cannot delete or update the parent row, the foreign key constraint order detail. Okay, I suppose references to the customer, I suppose, well, there are two foreign keys available. If you see describe table over here, it will show you DESC customer, describe table customer. Okay, describe table order detail. Order detail. So here there are two keys are available, and that's why order detail. Okay, just a minute. Order detail, we have this thing. Okay, let's do in this way. Let's drop table order detail. Okay, dropped. Again create the table, but at the time of creating table, I would like to add on delete cascade. At the time of creating table, on delete cascade. Can you see here? You just add on delete cascade. References customer on delete cascade. Now let's try to add these details. Again, I have inserted these. This is select star from order details. Let's not use this. Select star from customer, and yeah, can you see now? So here I have now delete is working properly. Let's try to fire again. Select. See, I have deleted customer. Now let's try to see. And can you see? Here I have deleted customer. So first customer deleted over here. So because of on delete cascade, here I can say select star from customer also. Can you see there is no first customer? So we have deleted the first customer. So here we have deleted the customer with one ID, and because of that the orders placed by particular customer also have been deleted. The orders placed by a particular customer that also have been deleted. So that is something called as cascading. What is cascading? What is cascading? In the relationships, cascade action follow. Cascade action allow for automatic propagation of changes across the related tables when modifying or deleting data. Common cascade action includes cascade, set null, set default, restrict, and on delete cascade. On update is also there, on insert is also there, right? So, but we have seen more appropriate, more real thing, that is on delete cascade. Well, here I have deleted the order detail table and created again. This is the one way. This is the one way. At the time of adding cascade, at the time of creation, and this is what altering on delete cascade foreign key. In the earlier case, what was happened? Foreign key was already there and it was pointing to that foreign key, and that's why it didn't work. But here I deleted the table and created it again. I hope you have understood the cascading thing, right? And other things are relationship, maintain the data integrity and the referential integrity, right? Cardinality and optionality means which table would be having how many records. We already have discussed these things, but cascading was a little bit important. I hope you have understood one-to-one relationship, one-to-many relationship, and many-to-many relationship. And here our topic ends. Well, if you have any questions, write it in the comment box. Write it in the comment box. If you have understood the thing, also write it in the comment box. I can add a lot of things related to this, but I want to keep it very simple. Okay. That's it for this topic. Thank you. Let's meet in the next video.